Okay, in this video we're going to take a look at counting subatomic particles. So subatomic particles are the three main components of atoms, and we have protons, which are positively charged. One way I remember this because proton starts with P, positive starts with P, so protons are positive. Neutrons actually have no charge, so this is a U, N-E-U. Neutrons have no charge, they are neutral, and electrons have a negative charge. So I will abbreviate often electrons with a E, a lowercase e, with a negative symbol on it. So protons are positive, neutrons have no charge, electrons are negatively charged. If we were to look at an element on the periodic table, so let's take carbon for example. On the periodic table, carbon looks like this. I've got a C with a 6 on top, and round to the nearest whole number, I've got a 12 on the bottom. So if I take a look at this, so this is an excerpt from the periodic table. The top number is the atomic number. So the atomic number basically tells me the number of protons, and in a neutral atom it will tell me the number of electrons. Okay, so this is only true in a neutral atom. The bottom number is the mass number, and the mass number, that's an S and S. So the mass number, well, let's try this, make it look a little better. So mass. The mass number is basically, like we said, we're going to round this to the nearest whole number. It's the number of protons plus the number of neutrons. So this is the protons, so this is my positive, and this is actually adding, so this is plus. So it's protons, so I'll do this. So protons plus neutrons equals the mass number. So if you want to find the number of neutrons, basically all that you have to do is subtract your top number from your bottom number. So if we were to look at carbon, so if we're looking at protons, neutrons, and electrons for carbon, so let's take another color here. So I have 6 protons. Because this is a neutral atom, I have 6 electrons. And the neutrons, I just take the 6 from the 12, which gives me 6. So there are 6 protons, 6 neutrons, and 6 electrons in carbon. So if we were to take another element, this time let's do oxygen. So oxygen on the periodic table looks like there's an 8 on top, and there is 16 on bottom, and my block looks like this. Okay, so now if I'm going to look at protons, neutrons, and electrons for oxygen.
Attention teachers, at this time you can make your way to...
Alright, so in this, protons, neutrons, and electrons, the 8 tells me that I've got 8 protons, and it also tells me I have 8 electrons, because they have to be the same in a neutral atom. And to find the neutrons, I take 8, which is the top number, from the bottom number, which is 16, and I'm going to get 8 neutrons there. So here I've got 8, 8, and 8. One thing you'll notice for the smaller elements, typically the protons, neutrons, and electrons will all be the same number, but that's not always the case. Sometimes in the bigger elements, and actually for most of them, this is not the case. But anyhow, so there are 3 other different types of atoms that you'll come into contact with. So we have just normal atoms or neutral atoms, so I'll put neutral in parentheses. So we have neutral atoms, and you have something called ions and something called isotopes. So going up to the top, in an atom, the number of protons is equal to the number of electrons. So in a neutral atom, the reason why it's neutral is because protons are equal to electrons. An ion is an electrically charged atom. So electrically charged atom. So electrically charged atom, which means it's got a charge, which basically means that the number of protons is not equal to the number of electrons. So be careful with ions. The only one of these two that we're ever going to change is the number of electrons. You can only change the number of electrons, because if you change the number of protons, you're actually changing what the element is. So for example, we've been working with oxygen. So oxygen has 8 protons, so this is oxygen. If I were to take one of these protons away and have 7 protons, well, that would no longer be oxygen. That would actually be the element nitrogen. And So actually this is a nuclear reaction. This is not chemistry, so this is not what we're doing. So make sure that you never change the number of protons. You can only change the number of electrons. So going back down to isotopes, an isotope is an atom or two atoms of the same element, with different mass numbers. Okay, so isotopes are two atoms of the same element with different mass numbers. So an example of this would be if I have, say, carbon 12 and carbon 14. So whenever you have it written out like this, whenever you've got the element symbol or the element word written out, this is a dash. This is not a negative, so this is the dash. And this number on the outside, so this new number here, or this number tells me the mass. So this tells me the mass here. So on the periodic table, the normal mass number for carbon is 12. So we don't really consider this one, I guess, the isotope, because this is the most normal one. And we'll talk about how these masses are calculated later on. But anyhow, the carbon 14 is an isotope. So what this means, if we were to do the protons, neutrons, and electrons for each one of these, so protons, neutrons, and electrons. Carbon, we said before, has 6 protons, 6 neutrons, 6 electrons. So we never change the number of protons. So carbon, all carbons have 6 protons. Okay. The protons and electrons are still going to be the same. So I've got 6 electrons, but the mass number is different. So the mass number is actually 2 higher than it is over on this side. So this means it's got 2 more particles than this one does. So the only particles that we can add that doesn't add charge but just adds weight is the neutrons. So if this one has 6 neutrons on the left, carbon 12, well, this one on the right has 8, says 8 neutrons, because we take 14 minus 6 will give me the 8. So here's an example of the isotopes. So going back up here to ions, so let's do a quick example for the ions. So an ion example would be, let's say if I have calcium, normal calcium, and I've got calcium plus 2. So calcium, if we do the protons, neutrons, and electrons for calcium, and then the protons, neutrons, and electrons for calcium plus 2, calcium has 20 protons, so that means it's got 20 electrons. So to find the neutrons, I take the top number. So on the periodic table, calcium looks like this. I've got Ca, 20, and I've got 40. So with our box, this is what it looks like. So to find the neutrons, I take 20 from 40, which gives me 20 also. So calcium plus 2, remember the protons never change, so I've got 20 protons. The neutrons, because I don't have a different mass number, the mass number is still the same for calcium plus 2 as just normal calcium. That means the neutrons have not changed, so I still have 20 neutrons. But now here's where the difference happens. I've got a positive 2 charge. So because electrons are negative, in order to become positive, I have to lose the negative charges. So if I start off with 20, and this plus 2 means that I've lost 2 negative charges, well then I'm going to end up with 18 electrons. So if we work this out mathematically, so let's choose a different color here. Let's choose yellow. So going back up to here, well, green. So if I work this out mathematically, so this is an arrow, a positive 20 plus a negative 18 is going to give me negative 2. I mean positive 2, sorry, positive 2. So positive 20 plus negative 18 gives me positive 2, which is exactly what my exponent is here, or the charge on this particular calcium. So to do these, you basically just look at, you can kind of reference it to the normal atom, which is neither the ion nor the isotope, and you can just calculate different ones. So let's just do one more really quick. So let's do, let's say for example, if I had something, so let's take oxygen. So let's say I had a negative 2 ion of oxygen, and so this time I'm going to compare it to just normal oxygen. So protons, neutrons, and electrons. Protons, neutrons, and electrons. Here, oxygen, all oxygens have 8 protons. So we're going to have 8 protons here. In a normal atom of oxygen, which is this one, I'm going to have 8 electrons here. And then to find my neutrons, I'm going to take 16, which is the mass number. minus 8, which gives me 8. So I've got 8, 8, and 8. Okay, here, this is just negative 2, so a negative 2 ion has the same mass as a normal atom of oxygen. So the nitrogen or the neutrons here is going to be 8. Here's where the difference happens. Here's a negative 2. So here, up at the top, calcium, in order to get a positive 2 for the calcium, I had to actually lose 2 electrons. But down here, because this is negative, I actually have to gain 2 electrons. So if I start off with 8 with a normal oxygen and I gain 2 electrons, now I'm going to have 10 electrons. So if I work this out mathematically, I'm going to say that I've got 8 from here, the protons. So if I've got 8 protons, and I'm going to add that to a negative 10, 8 plus negative 10 gives me a negative 2. Which is exactly the same charge that we have on this oxygen.